Hey, what's up, guys? Hey, I wanted to present you with Unit 12 test review, and I really hope this helps. All right, let's get started. All right, this first part here, we are going to take this piecewise function, and we need to write a new function for it. So here's the piecewise function. It says write g of x. All right, if it is, or if f of x is translated 6 units down. So guys, remember, 6 units down means you have f of x, and you're gonna move it down -6. All right, -6. All right, so simple. That's f of x. We're gonna move it down 6. Now, notice that the conditionals, x less than or equal to 2, won't change because this affects the y value. It's outside the parentheses. All right. Remember, if this was something inside the parentheses, that would mean right 6. All right. We're not looking at that. We're going down 6. So that has no bearing on x. That one did. That affected the x value. This did not. Okay. This did not, excuse me, that's down 6. All right, remember, down is a y-axis. All right, down 6. Even this one, okay, we're going to take that and move it down 6. So I'm going to do it out here. X plus 7 minus 6. 7 minus 6 is 1. So we have x plus 1. All right, and again, the condition did not change because it was not affected. All right. Alright, and that's my new feature right there. That's my chirp. Alright, whenever I do a problem and I finish and it's the correct answer, man, you get a chirp. Alright, I thought that was kind of cool, so I'm throwing it in the video, alright? Alright, this next one. We have the function here. Alright, and we are going to translate it 2 units to the left. Now remember, when you move something to the left, alright, this way, you have to do the opposite sign. So when you take f of x and you move it to the left, you actually have to do plus that value, so plus 2. So we take the x and we're going to add 2 to it. So here is the function. So the only thing that's affected here is going to be the x value. The x, we're literally going to add 2 to it to move this thing, to shift this thing to the left. All right, so I take this top part. I'm going to work it out here before I graph my g of x. Or not graph, but before I solve it out. All right, so right here we take the negative. All right, we're going to take just the x, okay? Just the x, and we're going to add 2 to it. All right, add 2 to it. And guys, that's it. That's your translation to the left. All right, some of you may be tempted to go, okay, negative x minus 2 minus 8. But if you do that, then you got to simplify the whole thing to have negative x minus 10. All right. So again, notice now, this is correct, guys. All right. It's just if you're tempted to simplify it, then this is also correct. All right. So I don't know how far in your class you got to take this thing. All right, but in my room, we're going to definitely simplify this guy. So I'm going to go ahead and put negative x minus 10, okay? Negative x minus 10. Now, I also got to show you this right here. See how this affects the x value? All right, the horizontal translation. Well, this also has to change, all right, because it's going to be x plus 2. All right, so I'm going to add 2 to this as well. So if I go x plus 2 less than 0, I need to solve that. So I'm going to go minus 2, and you get x is less than negative 2. So if x is less than negative 2, all right, and then we need to do this part right here. We have negative 7, and we go x plus 2. All right, if you want to simplify that, you can go negative 7x minus 14. All right, that is the same thing. Some of you guys, you'll see it like this. All right, on the test, it may be simplified all the way down to this. Okay. Now remember, we got to change this. All right, and I can already tell you if that was x, then you get the same thing, just respect the sign. So if x is greater than or equal to -2. All right, we got another correct answer, which means you get another buzzer. All right, I like that feature, man. I don't care if you don't. Some of y'all gonna hate, but whatever. Let's keep it going. All right. For this one right here, describe the transformation. Hey, this one's simple. We got the function plus 5. What does that mean? All right, g of x went up 5. All right, up 5. This one, all right, f of x plus 10. What does that mean for g of x? G of x moved left 10. So we have left 10, okay, left 10 units. This one means f of x moved right 1. So g of x is right 1. And this one right here, we just did this up here. All right, translated. See how this f of x minus 6, or the function minus 6, it went down 6. All right, there should be 4 buzzers, but since it's all grouped together, you just get 1. All right, appreciate it. Now, let's go ahead and look at these next graphs. We got to write a rule for g of x. All right, write a rule for g of x. G of x reflects f of x, so we got to reflect this whole thing across the x-axis. Remember, when you reflect it across the x-axis, all right, it is the negative outside of the x-axis, all right, negative x. So that means we got to put a negative outside this whole function. You reflect, matter of fact, let me explain it like this. You've got to reflect the whole f of x like this. F of x is reflected across the x-axis. So the whole thing gets negative. So what you have is negative x cubed plus 2x plus 3. All right, if you want to simplify that, distribute the negative to the entire thing. You're going to get negative x cubed, not plus, minus 2x minus 3. All right, and again, that's another correct answer, all right? So, let's take a look at this next one. This next one, we have x cubed minus x plus 3, and we're going to reflect across the y-axis. All right, so what that means is you have f of negative x. All right, the x will become negative directly to the x. All right, the negative is applied directly to the x. Not out front, but directly to the x in the parentheses with it. So we reflect, that means every x across the y-axis will have a negative. So you have negative x cubed. See how that's the same now? All right, negative applied directly to the x, not like the last one where the negative was outside. All right, so now we have minus negative x. All right, that minus is a part of the problem. This one is reflecting it across the y-axis. And then we have plus 1. So now let's simplify that. Negative x cubed, right? Negative times a negative times a negative, right? Negative times a negative is a positive, times a negative is a negative again. So that's still negative x cubed, all right? Then we have negative times a negative. Well, that becomes a positive. So positive x plus 1. All right, that is your simplified answer right there, okay? All right, now let's look at the next deal right here. We have x squared plus 2 vertically by 1/2, compressed vertically by 1/2. So what does that mean? You're going to take 1/2 and it goes outside because you take f of x and you multiply by 1/2, which means it goes outside. So I have 1/2 of x to the 4th plus 2. And when you do that, distribute your 1/2, you're going to get 1/2 x to the 4th. All right, and half of 2 is 1. So 1/2 x to the 4th plus 1. All right, and that is a correct answer, guys. That's how I know if I'm right or not. All right. For this next one here, number 10. Number 10. All right, g of x stretches f of x, x cubed plus x squared minus 6 horizontally, stretches horizontally by 3. All right, so remember now you got to use the reciprocal rule. All right, if we want to stretch it horizontally by 3. So you have f of 1/3 x. All right, f equals 1/3, f of 1/3 x. That stretches this by 1/3. So all the x values, let me make this a little bigger so I can have more room to write in between that line, is going to be stretched by 1/3. So I have 1/3 x cubed plus 1/3 x squared minus 6. All right, the 1/3 is applied directly to the x, okay? Now, what we got to do is cube everything, square that one, cube that one, square that one. All right, and that's just 6. So what you end up with when you cube this, what's 1 cube is 1. All right, let me thin this out real quick so I can. All right, 3 cubed is 27. All right, and x cubed is x cubed. So 1/27 x cubed. That wasn't my bell. That was the school bell, okay? And then let's keep going. Right here, you got to square the top, which is 1. You square the bottom, 9. All right, x, and you got to square the x squared, and then we get minus 6. All right, this is your equation for stretching this whole thing by 3. All right, so again, that's the right answer, people, okay? All right, so now let's zoom out a little bit. Hey, and I want to tell y'all, man, let me just review this for y'all. I know I simplified a lot of these, right? Like I simplified it here. Yo, this may be acceptable by your teacher. You know what I'm saying? Even these, go back and look at that before I simplified them all the way. Like this one, that's the answer. But these other ones, man, you may be able to simplify them. You know, you may not have to simplify them, not so much. Your teacher may just want you to identify this and just leave it like that, you know. So, you know your teacher, man. That's on you to decide, you know what I'm saying, where y'all go with that, okay? All right. Next, man, we have x cubed minus 3x. Write a rule and sketch its graph. All right. So here's x cubed minus 3. All right. We're going to translate 3 units up. All right. Translate this 3 units up. So what that means is you have f of x, right? And you're going to add 3 units up. So here's the function f of x, x cubed minus 3x, and we're going to add 3, all right? So that doesn't simplify any, all right? We just move it 3 units up. So all these points that you can see on this graph, like this one, move it up 3. This one, 1, 2, 3. All right. Some of these, 1, 2, 3. All right. Let me see this one, 1, 2, 3. So what you end up with is this thing right here. And guys, bear with me because I am not the best at drawing these graphs. All right, there we go. So that's my rendition of this graph, okay? Just move it up 3. All right. Next, oh, you know what I forgot? There we go. That's the right answer, okay? So now, this one over here, we're going to vertically stretch by a factor of 2. All right. When you vertically stretch, this thing, all right, what you have to do is multiply f of x by 2. All right. So again, f of x is x cubed minus 3x. So I'm going to go 2 times x cubed minus 3x. All right. And what you get is 2x cubed minus 6x, okay? So we got to stretch this thing by 2. So I'm going to take all these points right here. See, that's 2. If you multiply by 2, it's now 4. All right, and see this point right here, negative 2? If you multiply negative 2 by 2, it's now negative 4. All right, nothing else changes, guys. All right, you just stretch it by 2. So when you do that, you actually have, like even this point, if you multiply by 2, all right, you get negative 6. And that point right there, 2 by 2, you get 4. So we got something like this. Bear with me, man. Again, I am not the greatest artist. So I'm going to try. Oops. And then this thing's not even cooperating. Let's see. Oh, you get something like that, okay? Something like that. All right, here's the equation. Now again, your teacher may take it like this. They just want to see you multiply by 2. All right, or you can simplify it like this, okay? That's the right answer. Now, let's go ahead and look at this last part where we reflect the y-axis. All right, when you reflect the y-axis, what you have is f of negative x, okay? So we take our equation, and you need to know that all your x's will be negative, okay? Minus a 3 times negative x, all right? The x's need to be negative to reflect over the y-axis. Now, if you want, you can just take it and simplify it. Negative x cubed is still negative x cubed. And this becomes positive 3x because you have 2 negatives time each other. Multiply, 2 negatives multiply, all right? So there's your function right there. And if we reflect it across the y-axis, all these points cross over, all right? Ooh, yeah, at 1. All right, let me cross more of these over. Put these over here. So you have this now. Oh. All right. So again, man, I'm not the best artist, man, but you can see it reflected across the y-axis, all right? Give yourself a bell on that one, all right, if you got that, okay? Now, what we got to do is, oh, that's a misfire on the bell. Sorry about that. Now let's look at this next deal, man. It says graph each function, find the asymptote, or tell how the graph is transformed from the graph of the parent function, okay? So this right here is geometric. All right, the parent function would be this, 3 of x. All right, but we have a 2 slapped right in front of it, like so. All right, like so. So what that is a horizontal shrink. All right, horizontal shrink by 2. All right, or 1/2, excuse me, horizontal shrink, horizontal compression by 1/2. All right, so here's what happened. And I'm going to graph this. I'm not going to use this because I can't draw, man. I'm going to graph it on the graphing calculator so you can see it. So let's see here. All right, so what I did here, guys, was I went ahead and I put our parent function 3 to the x in the graph. And then I went ahead and put the equation that was given to us, 3 to the 2x in. All right, and I want to show you how this is the parent. This is a horizontal shrink by 2x. Remember, when the numbers multiply directly to the x, it does the inverse. See how this is 2 times x was really a compression by 1/2, okay? Horizontal compression by 1/2, and I'm going to show you. All right, here's the parent function, 3 to the x. Now, it's going to be shorter. All right, it's going to compress like this. All right, watch. See how this it's not as wide? All right, that's the blue one. This is the red, the 2x, 3 to the 2x. It compressed, okay, just like that. All right, so, guys, that's the right answer right there. All right, make sure you understand the difference between the stretch and compression, all right, of the horizontal. This is the horizontal compression, horizontal compression by 1/2. All right, by 1/2. All right. Now, this one, negative ln of x. Well, of course, the parent function is ln of x. So I'm going to graph this, then I'm going to show you the negative. All right, what does that negative do, guys? A negative in front of the equation reflects it, all right, across the x-axis. So where we have this, we're going to end up with, let's see if you reflect this thing, it would be like this. Something like that, okay? So let's have a look. Go to my calculator, and when you put it in the calculator, the parent function ln of x, and then you put the negative ln of x. This is a reflection over the x-axis. All right, and here's ln, guys. You just click that ln and then put x in the parentheses. There's x. All right, you hit graph. All right, let's see what it does. Ln of x, and then negative ln of x. It reflected over the x-axis. Don't forget, the negative out front, guys, means reflect the x-axis, okay? All right, give yourself a bell, man. Hey, I like this bell feature, guys. I really do. Hey, by the way, today's sponsor, man, I always got to throw me a sponsor in there. Which really aren't sponsors. That's what I'm doing. Yo, I'm drinking this great value, man. This great value water right here for y'all. You know what I'm saying, guys? Stay hydrated. All right, good water. Okay, anyway, let's see what we got here moving along. We have log of x plus 5. All right, the parent function, guys, will just be log of x. All right, log of x. Nothing done. All right, now here's what happened. This means plus 5. Well, we know that you do the opposite. Normally when we think plus, we go this way. But really, when it's plus, we need to go this way. That's x plus 5. It's not out here plus 5. That's not up or down. All right, it's left or right. So we're going to delete that. All right, it's left or right. And since it's plus 5, you go the opposite. You're thinking positive. Nope, go negative. 1, 2, 3. Well, actually 2, 4, 5. 5 is there. So the log this time, it's going to be like that. All right, so let me show you. The original was like this. But because of that left 5, it's going to be right there. Watch what I tell you. All right, so let's go to our calculator. Oh, there we go. And let's put it in. So here you see the parent function log of x. And then we have log of x plus 5. Again, that's left 5. Left 5. So here we go. Let's graph it and see what we get. There's the parent function. And then, boom, left 5. 1, 2, 3, 4, 5 right there. You see it? Just like I told you. All right. That's the correct answer, man. Hey, listen, make sure you know these transformations. They're the same. Regardless of the function, they don't change, man. They are the exact same stuff. Left 5. All right, very same stuff. Oh, what was this one? Reflect the x-axis. Reflect x-axis. All right, reflect the x-axis. Hey, I know I wrote that sloppy, so y'all listen to me. Reflect the x-axis, okay? All right, that's the front, man. I'm going to stop right here, actually, and make a whole nother video for part 2, because look at this, man. It's 24 minutes. All right, so I'm going to stop right there, okay? So give yourself a bell for completing the first part. Kudos to you, man. Hey, go pick up on video 2.